So good day. Today we will discuss about implicit differentiation. So for our objectives, we need to distinguish between functions written in implicit form and explicit form. And we will use implicit differentiation to find a derivative of a function. So here, let us first identify the function. Y is equals to 3x plus 5 is an explicit function. X squared plus y squared is equals to 25 is an implicit function. Y is equals to the square root of x cubed minus 7 is an example of explicit function. Y is equals to the quantity of 5x minus 8y raised to 4 is also an example of explicit function. And for our last number, 3x squared plus 5y is equals to 9 squared minus 15 is an example of implicit functions. So here are some guidelines that we can use in solving implicit differentiation, or for us to solve for implicit functions. So first is to differentiate both sides of the equation with respect to x. Then collect all terms involving dy over dx on the left side of the equation and move all other terms to the right side of the equation. Number 3 is to factor dy over dx out of the left side of the equation, and last is for solve for dy over dx. Now let's have an example. So in our example, y raised to 5 plus 2y equals to x squared. The first thing we need to do is to differentiate both sides. So y raised to 5 plus 2y is equals to x squared. And if we differentiate both sides, it will become dy over dx times the quantity of y raised to 5 plus 2y is equals to x squared. Then, the next thing that we need to do is to find the derivative of each term. So this is the first term, second term, and this will be the last term. The derivative of our first term will be 5y raised to 4, and the derivative of y is y prime. Then, the derivative of 2y is 2y. It's actually 2, and y, derivative of y is y prime. Then, the derivative of our x squared will be 2x. So it seems like all of our terms with y prime is already on the left side. Now, since all of the terms with the y prime is already on the left side, we will now factor out y prime. So our answer would be y prime times 5y raised to 4 plus 2 is equals to 2x. Since we already factored y prime out of this equation, we will now divide both sides by 5y raised to 4 plus 2 in order for us to cancel this equation so that y prime will be the only one remain on the left side. 5y raised to 4 plus 2, then we'll cancel this equation. So our final answer would be y prime is equals to 2x all over 5y raised to 4 plus 2. So next, let us have an example that includes product rule. So in this, we were asked to find dy over dx given that x squared y plus xy squared is equals to 7x. Again, the first thing that we need to do is to differentiate both sides with respect to x. So x squared y plus xy squared is equals to 7x. Then, after this, we will now try to find the derivative of each term. And the derivative of x squared y using product rule is, so let us have product rule, u v prime times u prime v times u prime v. Actually, it's plus, sorry. So, our u here is x squared. And our v here is y. So, y prime is y prime. Then, our u here is x squared. So, we will now add the derivative of x squared is 2x. And we will just need to copy our y, which is y. So the derivative of our first term is x squared y prime plus 2xy. Then we were asked to find the derivative of our second term. So again, using this formula, our x is, so our u is x, and our v prime is y squared. So the derivative of y squared is 2y y prime. Then add our x here is what? Our u prime here is x, and the derivative of x is 1 times copy y squared. So the derivative of our second term is x 2y y prime plus 1 times y squared is just y squared is equals to the derivative of 7x, which is 7. After getting the derivative of each term, we will now move all of the terms with y prime on the left side. So it will become x squared y prime plus x 2y y prime is equal to negative 2xy negative y squared plus 7. After moving all the terms with y prime, we will factor out y prime. And once we factor out y prime, the answer would become x squared plus x 2y. And if we divide both sides using x squared plus x 2y in order for us to cancel this equation, x2 plus x2y is equals to negative 2xy minus y squared plus 7 all over x squared plus x2y. Then we will cancel this part. So our final answer would be y prime is equal to negative 2xy minus y squared plus 7 all over x plus 2xy. So in this example, we just arrange x2y to 2xy. Then next is solving for trigonometric function using implicit differentiation. So kindly screenshot this formula that may help you in solving or in deriving the trigonometric function. So first, let us have an example. So we were asked to find dy over dx given that tan y is equals to 5x. So same process, differentiate both sides with respect to x. Then tan y is equals to 5x. Then if we already differentiate these two terms with respect to x, we were now find the derivative of each term. The derivative of tan y is secant squared y, and the derivative of y is y prime. Then derivative of 5x is equals to 5. Then we will factor out y prime. So the answer would become secant squared y. We will divide both sides by secant squared y in order for us to cancel out, and the y prime will be the one that will be left. So we cancel this equation. Our final answer would be 5 over secant squared y. So again, looking back at our trigonometric differentiation, as you can see here, our tan, if the derivative of our tan is secant squared. So that's it. I hope you've learned something. So goodbye.